Alkene Nomenclature. Let's look at the characteristics of alkenes, starting down here. They all conform to this formula if there's just one double bond and only carbon and hydrogen atoms. They are unsaturated, in this case, and they are part of the aliphatic group of hydrocarbons. There are straight chains and branched chains. Let's look at the first member of this family. It's called ethene. That's the UPAC name. Its common name is ethylene. Ethylene is so well entrenched in our language that you have to know both names. Here's the molecular formula, the structural formula, and the condensed formula. You need at least 2 carbon atoms to form a double bond, so there cannot be a molecule called methene as there is a methane in the alkane series. The boiling point is minus 102 degrees Celsius, which means at room temperature it's a gas. It's a very small molecule, but if you combine many hundreds, around 500 or so together, you get a solid polymer called polyethylene. This is a source of many kinds of polyethylene plastics. For example, grocery bags and certain plastic wraps are made of low-density polyethylene. Hard hats, some toys, and milk jugs, for example, are made of high-density polyethylene. It's also part of ethylene glycol, which is the main ingredient in antifreeze. The next member in the family is propene, UPAC name, and propylene, the common name. Here's the molecular formula, structural formula, and condensed formula. The double bond can be here or here. These are the same molecule. Only one double bond is possible with 3 carbons. So although propene is acceptable, you will often see it written as 1-propene or prop-1-ene. All 3 are acceptable. Propene boils at minus 40 degrees, so it is a gas at room temperature. However, as with ethene, many propene molecules can be strung together into a solid polymer called polypropylene. Many different polypropylene plastics are made, such as this yellow rope, plastic caps, syringe needles, and yogurt tubs. Let's now look at the nomenclature of alkenes and start with this, a 4-carbon alkene called butene. We need to locate the position of the double bond so that we can name it correctly. We number the carbons from the end near the double bond. Here is our numbering, and we consider the double bond to start at carbon 1. So this will be called 1-butene. If the double bond is in the middle, it doesn't matter which way we number the chain. From the left end, the double bond starts on carbon 2, and the same if we start from the right end. The double bond begins on carbon 2 either way, giving us the name 2-butene. Let's now look at 1-butene with a substituent. We number the position of the substituent, followed by the parent name. Methyl is on carbon number 2, so this would be 2-methyl-1-butene. In this example, a chlorine atom is attached on the left side. We'll number from the left side so that chlorine will have a lower number. Methyl is on carbon 2, so the name is 1-chloro-2-methyl-2-butene. What if the double bond was not in the middle but on the right side? How would the name change? We start numbering now from the right, because that's where the double bond is. Now chlorine is on carbon 4, and methyl on carbon 3, giving the name 4-chloro-3-methyl-1-butene. Instead of writing 1 or 2-butene, it's also correct to write 1 or 2 inside butene as shown here. This method of naming started around 1993 from UPAC, and although it doesn't seem to make much difference for these smaller molecules, apparently for large molecules, it is a much clearer naming system. Finally, you can pause and try this if you like. This is 3,3-dimethyl-1-butene, or 3,3-dimethyl-but-1-ene. Here's a few practice problems, so you can stop, try them, and come back. The first one is 2-methylpropene. You can also name it 2-methyl-1-propene, or 2-methylprop-1-ene. This is 2,4,4-trimethyl-1-pentene, and this is 2-chloro-2-butene. This one is tetrasubstituted with 4 bromines. It's very simply called tetrabromoethene. If you like, you could be more specific with 1,1,2,2-tetrabromoethene, although the first name is preferred. What's wrong with this name? Draw out the structure according to the name shown here, and discover why it's wrong, and then write the correct name. Here's the answer. If you didn't get it, I'll go over the thinking. First, draw a 2-butene condensed structure, and choose, say, this carbon as number 1. Then add chlorine to it, and complete the numbering. Put methyl on carbon 3, and also ethyl. Notice that the addition of ethyl changes the longest chain to 5 carbons, thus making this a 2-pentene. Now we have chlorine on carbon 1 and 2 methyl groups on carbon 3. The longest chain takes precedence over location of the double bond. Let me explain this after looking at this example first. Here we would number the chain as usual so that the double bond is part of the longest chain and also has the lowest number. This would make it a 1-butene with ethyl on carbon 2, giving us the name 2-ethyl-1-butene, or of course 2-ethylbut-1-ene. Now let's look at it again, this time numbering the longest chain without concern for the location of the double bond. We number the chain like this, giving us a pentane. The double bond is now on carbon 3. We could have numbered it from the other direction as well and still have the double bond on carbon 3. In 2013, the organization UPAC, or IUPAC, introduced this new rule for alkenes. This group is called methylidene. You recognize the ENE as denoting a double bond. We now put them together to obtain 3-methylidene pentane. It is strange looking at first. Note that this is a recommendation only by UPAC. The previous 2 names are still correct and recognized by UPAC as acceptable names. And finally, let's look at alkadienes. These are aliphatic hydrocarbons containing 2 double bonds. For example, the 2 double bonds here are signified by the ending -ene. So instead of just butene, we write butadiene. The double bonds are located on carbons 1 and 3, so the name is 1,3-butadiene. It can also be called buta-1,3-diene. How would you name this one? It's the same molecule except with methyl on carbon 2. Hence 2-methyl-1,3-butadiene, or 2-methyl-buta-1,3-diene. How about this? It's again a 1,3-pentadiene. Just locate the double bonds correctly and get 1,3-pentadiene, or penta-1,3-diene. How about this one? It's the same molecule, except with methyl on carbon 3 and fluorine on carbon 4. Note the alphabetical order. The name is 4-fluoro-3-methyl-1,3-pentadiene, or 4-fluoro-3-methyl-penta-1,3-diene. If a molecule has 3 double bonds, the name would be a triene, and with 4 bonds, a tetraene. One last question. Draw the structure for this compound, try it on a piece of paper, and then come back. I would start by writing 6 carbon atoms, put a double bond on carbon 2. I'll start from the left side, another one on carbon 4, add methyl groups on carbon 2 and carbon 4, then fill in the hydrogens so that each carbon has 4 bonds. Is this what you got? Probably you did. This ends the video on alkene nomenclature.